Now we're still looking at finding the sum of so many terms in an arithmetic sequence, which is an arithmetic series, but just the way they give the problem is just a little bit different. And we're going to look at number 65 right here. Now notice they list out the first few terms and they tell you that n is 7. So we're finding the sum of the first 7 terms. Well, I know what a1 is. a1 is my first term. I also could figure out d if I'm given my first few terms. Remember, d will equal, take a term and subtract the term in front of it. So 31 minus 24. So d is 7. So notice you're adding 7 here to get from term to term. Okay, so d is 7, a1 is 24, n is 7. So I want to use this formula, Sn equals n divided by 2 times a1 plus n minus 1 multiplied by d. So I'm finding the sum of the first 7 terms. I'm going to take 7 divided by 2, and I'm going to go 2 times a1, which is 24, plus n minus 1 is what the formula says here. N is 7, so that's going to leave me with 6 multiplied by d, and over here d was 7. So I have 2 times 24 plus 6 times 7 inside my square brackets there. I'm going to go ahead and do this division right out front here. That's 3.5. And this will be 48. 2 times 24 plus 42. 48 plus 42 is equal to 90. And then I'm going to take 90 times 3.5. So S7 or SN, 3.5 times 90. You do that on your calculator is 315. Then we get into something called sigma notation, like on 71. So I want to look down at 71. And I've got some notes about sigma notation on your reference sheet. Okay, and this is the sigma symbol. Kind of looks like a funny looking E. So basically what this means is they give you a little expression out behind this sigma symbol, and it would mean you'd have to plug in every number from 1 all the way up to 30 and sum all of those together to figure it out. Now, by plugging, if you'd have to plug in every single number from 1 to 30, that would take a while. And I have a shortcut. Okay, we're going to use this formula, Sn equals n divided by 2 times a1 plus an. So kind of the shorter one of the sum formulas that we've been dealing with here. And to find a1, as a note on the sheet, I've got you plug in the number below the sigma symbol. So I plug 1 into this expression right here. So I would have 10 times 1, subtract 5. So if I do 10 times 1, that's 10 minus 5. So a1 would be 5. An, which would be my last term, is I plug in the number up on top the sigma symbol. So the very last one I'd have to plug in, which is 30. So if I put 30 in there, I would have 10 times 30, subtract 5. Well, that'd be 300, and then subtract 5, that'd be 295. So I know what a1 is, I know what n is, 5, and then I know what an is, 295. So I really know these two things inside my sum formula. N is going to be how many you'd have. And I got a little shortcut on there, and I say n is top number minus bottom number. Okay, meaning the top number on top of the sigma symbol minus the number on the bottom, and add 1. So in this particular problem, I would just do 30 minus 1, and then add 1. 30 minus 1 is 29. Add 1, it's 30. So I'd have 30 numbers, or 30 total things I'd have to sum up. Now, key thing with sigma notation, it doesn't always start with 1 on the bottom. So that's why you got to be very careful. In this case, we end up being what's on the top number there for n. So if I go ahead and put that up in here, I'd have 30 over 2 out in front there. So Sn would equal that. So Sn equals 15 multiplied by 300 if I add my 5 and 295. So Sn equals, and if I do 15 times 300, I get 4,500. Okay, so that's a lot faster than having to plug in every number from 1 up to 30. problem we're going to look at, and that is number 83 right here. And let's blow this up. Now we're going to determine the number of terms. We're going to kind of work backwards in a sum formula. And you are going to use this formula that we've been using, the shorter one of the two. So n divided by 2, a1 plus an. So notice they give me the sum here. I'm trying to find or determine the number of terms n. I'm going to solve for n. So all you're going to do is algebraically set this up. So I've got 255, that's my Sn, equals n divided by 2 times a1, which is 3, plus an, which is 31. So I get 255 equals n over 2, or n divided by 2, times 34. Now there's a couple different ways you can do this. What I'm going to do is I'm going to get rid of this divide by 2, so I'm going to times by 2 and cancel it out on both sides. If I take 2 times 255, I get 510 is equal to, and then I have n times 34 left. Well, now I'm going to divide by 34, and this will give me the number of terms n, and if I divide that, I get 15.